If we gave it a remote control, could a plant decide where it was going to grow? Because we know that plants follow light, they're phototropic. And so, we have the classic image of the sunflower turning its head, or you've probably seen in your house if you have plants near the window, they're kind of pointing in the direction. It's like, well, what if we move the light?
Yasmeen Hitti, PhD candidate at McGill University.
Plants, people think they're stationary, but actually they do move, but it's through growing. It's at the very tip. So they are navigating a space, but at a very different time scale than us. Everything seems slower because we're not seeing a lot of things happen, You're lucky if you're catching a bloom in motion, you're seeing a leaf unfold, but we're at a time scale that's so different. And so seeing a quick response like that is like, oh wow, what's going under the hood? What's happening here? What are things that we cannot see? And so even in, a few minutes of data collection, seeing that a response is different was kind of amazing.
You mentioned that plants communicate to each other. What do we know about that so far?
So plants have what we call volatile organic compounds, which are these like micro traces of gases and that are there. So you can think about a plant when you see it, there's maybe this like thin cloud that we're not seeing. That is passing. If there's a neighboring plant, it can sense. And so when there is a stress or there's something else, composition of this gas is going to change and the other plant's going to sense it. And so that's typically how they would communicate above ground. In fact, I think this was in Japan. They put some scaffolding along this huge tree and they cut 90% of its leaves. So to stress it out, they chop, and then they measured within a radius of 2 kilometers or something. And they were seeing how far is this gas going. So the other trees were protecting themselves thinking this was coming. And so it's kind of interesting knowing how far, they can spread a message and how much time as well.
Bonded by Science, proudly presented by Noble Blocks.
Yasmeen, thank you so much for joining us on Bonded by Science. I'm very much looking forward into diving into your research. I know you're working on a lot of projects, and I think that will come out naturally as we go through our conversation. But the one that we'll probably start with is your work at the intersection of plant science, robotics, the Internet of Things, wearables, and AI. Did I cover all of the main 5 points of intersection?
Yeah. No, it's good. It's funny when I'm hearing someone else tell them to me. I'm like, that's loaded.
That's loaded. Yeah. Well, I became really interested in before I started doing my university degree, in my PhD work, I became super interested in a book called The Body Electric. It was one of the first books that looked at understanding or tried to understand and report on why people have magnetic fields around them and whether or not you could alter those fields to promote bone growth. And that was some of my early introduction into many areas of science that I work and operate in now. And The Body Electric was actually a book that was kind of rejected in a way, like the science that it contained was rejected from the scientific community in its early days. It's not now, but when it first started. The work that you're doing now it has a similar premise on plants. Can you tell us a little bit more about how my mind went to Galvani's, twitching legs, frog legs?
Yeah.
Yeah.
So I think the idea of a plant, electrical fields, magnetism, and they're all part of the, types of energies, let's say, that if we're going to talk in basic terms here, is just what could affect a body. And I think the concept of plants having nerves or having electricity going through them is something very foreign. And we have a very hard time thinking about intelligence or electrical connections that are meaningful or mean a action or movement or chemical reaction inside another body than a human, because we are the center of the world, right? And so there's a little bit of a rejection of this. There's also some very hot debates within the research community where people talk a lot about, are plants intelligent? So should we be allocating this type of word to it? Even a conference I went to, I think they used to call it plant intelligence, but they've reverted back to calling it plant signaling and behavior to be less loaded. And so the concept of one, either stimulating the plant with electrical signals or recording their electrical signals is still kind of mystical to some people, but yet there's a lot of experiments that have been done and it's been advancing. And one of which is, I think it was someone in the US who put a lie detector test on a plant. And that was really something that was novel at the time. I mean, they weren't checking if the plant could lie, but essentially to see, do they know someone's in the room or not? And irrespective of putting that sensor on or not, plants do know when you're in the room.
That's fascinating. So it opens up the premise that they're mad that you left for the day, and it becomes like your dog or your cat.
Well, I don't think we know what happy means for plants too. Like
No,
if we're
I
gonna
know, I'm
say
just
if they're
teasing.
mad, but yeah.
Yeah. But it does, I mean, again, I think this comes down to how we define intelligence or how we define life. Yeah, I think we could get really philosophical very fast in this podcast. But maybe could you remind me, what is, you're doing your thesis now, right? Your PhD. It would be correct to call you a PhD candidate, right? You're planning to defend in the near future?
Yeah, so I'm actually in the process. I just finalized my committee, and so my initial copy of my thesis is going under the first official review. So I'll be probably defending early 2025.
Great. And what was the title of your thesis?
The title of my thesis is Integrating Plant Behavior with Technology, a Design Methodology and Analysis for Light Stimulus.
Okay. And for someone that is not used to reading academic titles, how else would you explain that?
So it'd be like, how would you interface a plant with tech to make it ergonomic for our plant? And so could we leverage its own responses to the world via technology, just like how we're doing it with humans? So thinking about a Fitbit or, how phone applications are nice for us. It's kind of making tech accessible for something that is non-human.
So this concept of plants have wearables it's not science fiction anymore. It's something that people are working on. You are one of them. Why would we what prompted this? Why would we want to create a so-called wearable for a plant?
That's a good question. So I think I came into my PhD a little bit with some whimsical energy, if I'm going to be honest. And it started with, I had this very a low grade sensor, and I wanted to see, I think it was like a EKG sensor, not even ECG or EEG. It was like a heart rate sensor for a Raspberry Pi. And I wanted to see, if I put different colors on the plant, am I going to get something? And it kind of was a whatever, let's have fun. And this was at the end of my master's, which even it took time in between getting back to my PhD. So it's something that sat with me for a little bit. And I saw that it was different and it kind of freaked me out.
What did you see was different? You had the low grade EKG sensor was connected to your Raspberry Pi, and then you placed it on different colored plants, or plants under different color?
Plants under different colors. So I come from a lab that looks at controlled environment agriculture. So we have a lot of quirky specialized LEDs, different wavelengths. So that means just different, very specific colors, light intensities. And so someone had something set up on a bench in the lab. And I think I looked at the amber lighting, blue lighting, and then dark, something like that. And we could see that the waves are different, even though there's a lot of software or firmware already on this sensor. So just already being able to capture that was kind of cool.
What did you find? Like between the different lights?
So we just saw that the patterns were different, or like dark looked completely different. And this was measurements of like minutes, right? So just seeing a quick response, because plants, if you think about them, people think they're stationary, but actually they do move, but it's through growing. It's at the very tip. So they are navigating a space, but at a very different time scale than us. And everything seems slower because you're seeing it not like we're not seeing a lot of things happen, you know? You're lucky if you're catching a bloom in motion, you're seeing a leaf unfold, but we're at a time scale that's so different. And so seeing a quick response like that is like, oh wow, what's going under the hood? What's happening here? What are things that we cannot see? And so even in, a few minutes of data collection, seeing that a response is different was kind of amazing.
And what exactly are you measuring? Like, to say that I saw a different pattern, one would say, well, a different pattern in what? Like, what is the actual data point that you're collecting?
Yeah, so for an EKG, I'm not 100% sure if it's passing like a certain voltage and reading the difference. So that would be a difference in potential. The sensors that I've built, that is what we're doing. So essentially we're stimulating, we're like shooting 3.3 volts through the plant at a certain place, at multiple places, and we're reading the difference higher up. So it's the difference in voltage. So it's like a resistance, really, is kind of how we could think about it.
Okay, that sounds like resistance. Yeah.
Yeah.
Yeah. Okay. So the wearables, or I guess the IoT devices that you're building, you place them on, I guess they're having two different points, obviously, if you're going to measure the difference in voltage or resistance. And then how did you choose like the voltage, and how do you choose where to place the 2 points? Is that part of the experimental process? Like, do you sit there and like dial up and dial down the voltage? Do you move the 2 points like a little inchworm would be moving like up the plant stalk? How did you decide?
So that was a great question. It was,
It's my job.
yeah.
Thanks.
I'm just
Thanks for
having
noticing.
flashbacks of when I'm setting up my first experiments. It's like, oh god. Um, so there are different techniques, just quickly, that kind of measure either the difference in potential, or they are actually not looking at the difference in potential, but just recording the electrical signal within the plant. So that works a bit differently. In my case, a lot of the techniques are puncturing through the stem or at a leaf point. And I thought, you know what? If I want to deploy something that maybe will be used in the world, I kind of want to have something that's non-invasive. So I went for something that was on the stem and it was at the surface. So I had to use some conductive gels on my probes. And deciding on the location was, okay, if I'm measuring at one point, and so this was the first time I was doing it, should I measure where the top world meets underworld, kind of? So the closest point in the stem that is connecting to the root system, because what happens above ground is different than below ground. So is there an exchange happening there? Is that where, if you think about it in terms of like piping or in circuits, it's like, is that where, everything has to go back down or up because they're exchanging nutrients, there's water flowing. This happens at everywhere in the plant, but inevitably the exchange between below and top, that's kind of where I was thinking. And it was thick enough and a robust location to think about. So that was one. But then I measured it. I wanted to do kind of a like brain mapping equivalent, but for a plant. And then I picked 5 locations. And that was kind of a pain. So I picked along the stem again, but the top of the plant is way more fragile.
Okay. I think the choosing the location, like you said, at the stem, just like a little bit below, I guess, under like where the soil would come, and then above that, because yeah, you have a different, the environment is different. You're definitely going from light to dark, right? And
Yeah.
yeah, it's definitely a transition point for sure. And I suppose if you are looking for um changes in electrical signals that could potentially have a lot of information in them, you want to go for a point where you expect there to be a lot of change first, before you go for another point where you expect to be very, subtle differences. So I think that was, some really pretty good thinking, I guess, as what I'm trying to say. It makes a lot of sense to me, why you would have picked that location. Can you explain to people that may be less familiar with, like, when you talk about electrical signals, how are electrical signals actually generated in a plant? So we're not arguing that they exist. We know that they do. You can measure them. Anyone can measure them. Um, but what is the what are the sources?
So a plant's composed of a lot of different molecules, just like humans. And forcibly, for things to travel along, it's like if we had a matrix of a lot of different things, well, there's things that are consistent, like calcium. And these have a charge that can change between a certain range. And so they're exchanging. And this is the either, well, anions or cations that are just flowing through. And there are kind of these barriers. So there's certain chemical reactions that can take a certain charge, and then this kind of has this domino effect that will ripple through the plant. And there are certain points where, and this is very at a like tiny microscopic scale, just for context, where at some point, this reaction requires a higher amount. And so this will kind of fluctuate what can be exchanged or not, but also be a barrier as to what molecules are passing or not. So what you're seeing really is kind of a um, exchange or messaging between different molecules will be the charge, which is what we're seeing as a resistance. And if we're comparing it also as also the concept of resistance is usually when you're looking at a circuit, a resistance doesn't really change over time, nor does it change if you flip the polarity of how you're measuring. But here it's like you're playing with a live wire. So it changes over time. And not only that, it's not the same if you're measuring in the different direction. So that's kind of interesting thinking about it in that way.
For someone that is on the outside looking in, they may be like, why would we fund research to measure electrical signals on plants? Could you enlighten us as to, like, some of the rationale that went into, for example, like convincing a funding body or even convincing you personally? Like, this is your time. Like, you've spent like I'm guessing maybe 2, possibly 3 years. I don't know how long you've been doing your PhD for. Some people do 4 years.
Longer. I'm going to finish in 5. I've had a lot of like ups and downs of it. Yeah.
Yeah. So it's a huge chapter of your life. So what would be some of the reasons that one would spend time, essentially placing electrodes on plants?
I've had this question a lot. I was just purely interested, but people love having applications. So one of which is plants are probably some of the best biosensors out there in the world. Again, earlier I was talking about how they're stationary. So when they're faced with an issue in the world, let's say a high gust of wind, some very acid precipitation, a bird coming to attack it, we can name all kinds of use case scenarios here, but point being is it cannot just get up and move like us where we're like, oh, danger, let's get out of here. They're like, oh shit, we need to deal with this right now. And so they have an amazing capability of adapting and we can say resilience. I'm trying to not personify the plant too much, but the point being is they're able to sense all of this and kind of come up with a like reaction to it, either it being chemical, like changing if their leaves are going to taste more bitter, or knowing that, okay, this type of danger has come before, so I can be more relaxed, hence not, starting again a chain reaction of things internally to disrupt my cycle that is happening every day. And so being able to measure, this is just kind of a context for measuring electrical signals on a plant, it's kind of like tapping into what's happening in the unseen for us because they are seeing things that we cannot see. Um, like in terms of gas, in terms of weather fluctuations, they're way more sensitive than we are. And so I think there's some interest in that for like probably weather stuff, but also catching something on a horticultural or like agricultural application. If you are capturing something that's happening internally in the plant before usually physically seeing it, because computer vision is a huge thing in agriculture. Sometimes things happen before you start seeing yellowing on the leaf or a change of the hue of green you're capturing. And so it's a little bit more intimate. It's a window into the before. And it's much more plant centric than a camera. Still, you're seeing the outside and not seeing the inside. And I think finally, too, it's just something, there's a whole other world of like interacting with gardens and plants. And I mean, the list can go on. But if we had to be really applied, that would be one of it.
Yeah. I think it's quite fascinating to learn that plants respond defensively to a predator, essentially. So I never really considered that plants play defense. I mean, I mean, offense, yes. Like they like to survive. I know, they grow towards light. We know that. Most people know that. But to think that they will change like the bitterness of their leaves because they're responding to some form of, well, we would call it aggression, but they're responding. Somehow they have. Maybe this is like evolution, or I don't want to go there, but they have a response that's somehow built in, that they can sense when maybe their leaves are being attacked. And I guess it's like you said, birds, but what about, it could also be
Insects.
like,
I mean,
yeah, insects, and
I'm
I
like,
would
don't quote me on the birds.
don't worry, they're not real. Just kidding. Yeah. So yeah, but I understand what you're getting at. I think insects for sure would be one. That would be like a much more natural, like our brains would more naturally gravitate to say, yeah, it would make sense that they would secrete something, or that they yeah, I guess they have, I don't know. Are they furry? Like, do they have little hairs on the leaves? I think some leaves are furry, right?
Some leaves are furry. The stems are furry too. That also is like very sensitive.
I can imagine. If you think about the
Yeah.
hair on your skin,
Yeah.
when you go outside and the wind blows, like that's how you get a good sense of the wind through the hair on your skin. Not only the hair on your skin, but definitely on the hair, on the follicles. To think that plants are also using that furriness potentially as a signaling mechanism, that's really cool. Because it's very hard, I think, as you said, like it's very hard not to personify the plant, to give it human-like qualities. Because, well, is that so wrong? I mean, that's how we understand our world, like through our own senses. So why would we at least identified with the plant?
I mean, like furry or not too, the plant is covered, has a film or a thin layer of like wax also surrounding it. It's like, that's the first barrier of entry where the first contact of anything between wax and then water world, let's say, inside is there's just this little amount of information that can come in or not, and seeing how that reacts to you at the surface. And just think about your epidermis or your skin too. It's like, I'm not saying we're hydrophobic, but there's some similarities in terms of like, toughness of the skin versus what's really inside of you.
Yeah, for sure. Yeah.
It's hard to not personify
and draw out the similarities and the parallels. And I think the more you know about the human body, the more you'll see the similarities and parallels of how plants are, like the physiology of a plant as well. I was curious because you sent me a paper that talks about an application or a modeling or simulation, it almost, to me, it looked like a game, and I wanted to play it because
It is a game.
is it a game? That is so cool. So it's called Grow Space. That's what you named it. So what was the inspiration for Grow Space, and can you why did you guys develop Grow Space? What is it too for those that are listening?
Yeah, so Grow Space is kind of a Atari-looking game. I developed this I took a class in reinforcement learning. I tried to take all computer science classes in my PhD, and I thought, okay, I have to have a final project for this class. COVID was hitting, and I said, okay, I'm going to give it a shot. And so the idea, and this is really what I was trying to center my entire thesis on originally, was could a plant decide, if we gave it a remote control, could a plant decide where it was going to grow? Because we know that plants follow light, they're phototropic. And so, we have the classic image of the sunflower turning its head, or you probably seen in your house if you have plants near the window, they're kind of pointing in the direction. It's like, well, what if we move the light? What if we can think about a plant, let's say in a 3D printer setting, deciding instead of, an inkjet, but kind of a light that's moving on an axis, could it decide where it's going? Or could we also shape plants first, thinking it as how we can do it, but then also closing the loop and like bioelectrical signals, for example, could it decide where it's going to grow? And so first was like, okay, well, doing this in the real world, it's going to be long, it's going to be costly, and trial and error is very long for anything plant related, even just getting it to day 14 of growth, so you're already 14 days out, and then you have to repeat and repeat. So let's simulate it. We can make a low resolution kind of rendering of this because we want to train it with algorithms after and see, one, is this a complicated problem for computers or like algorithms to play? If you give them a set of actions of they can displace the light, they need to grow to a target, do they even know how that's going to do it? And so it's shaping it kind of in a what is called a Markov decision process. So you are gamifying it, you're giving reward, it's based off of it's going in the right or wrong direction. And then they're learning the best policy to grow a plant into a shape or towards a certain direction. So that could be where there's in this case was like there was a target that was red, but sometimes we even went further in the background. There was it comes from a famous data set called MNIST that's used in machine learning. So it's like these numbers. And so in the back, it's like there's a 0, a 1, it goes up to 9. And like, can you actually drag the plant that's kind of looking like a circle, a light beam, to shape a plant in the shape of 0 or 7? Is this doable?
So when I looked at Grow Space, and I thought, okay, that's pretty cool, because a few ideas popped into my mind. One of them was like, well, let's say, like looking forward into the future, let's say you have limited amount of space to grow a plant. Then you could potentially design a light source that would move, that would optimize, the branching, the sprouting, and the growth in that way. Because not all plants grow with thick, with a thick bush, right? Or they'll just go straight up. If the light is straight up, they'll just go straight up. But it sounded to me like if you wanted, and if you were to set this up for real, let's assume that you had 10 years to do the PhD, you could actually make it, you could make it wind around, that ivory tower.
Yeah.
Even though it wasn't necessarily a climbing vine, theoretically speaking, of course. So I was thinking like, oh, that's cool. Like you could think of a lot of places. Like, for example, you could have some dark areas, and if you wanted to guide a plant towards a source of consistent light to make it more stable in the long run, you could do that essentially by, providing the helping hand in the beginning, which is like providing, artificial light to guide it to a point where it could actually get consistent natural sunlight. So as I read your papers, I was like, my brain was going wild, and I didn't think that I would be so excited about reading about plants. But I think when you put it in the context of understanding like how the plant operates, how it can move, why it moves, that it has this defensive mechanism, and when you think that you can actually control its growth, oh wow, there's just so many new possibilities come. Not for the sake of just having control, but for the benefits that you could potentially extract by exerting that control. So I thought that was super fascinating. And I still think I would like to try the game because I also see like there could be like you could learn a lot about the physiology of plants, the physics behind growth. I have a background as a neuroscientist, an engineer slash neuroscientist, and so of course I'm thinking about neurons and how they sprout and the branching there. So I saw a lot of parallels there. Of course, the signaling mechanisms are different between plants and a neuron, but maybe the logic and the rules for sprouting could have emergent qualities to them, as we see in so many other parallels in our world, in our universe, actually.
Yeah, I also think there's a lot of parallels to be drawn. And also this, just to, clarify too, it's like this really started with a branching algorithm that comes from something called the space colonization algorithm. So it's kind of like a particle simulator, honestly, at the moment. And so the beauty about this is that you can keep adding more rules or real life data. This was really gamified as to it. The branching right now really mimics more like the venation in leaves. And so, when you look at a leaf real close, you see they're not veins, but it's called venation. Um, Kind of like how it goes towards the outward tips of the leaf, and you see how the water's pipes, let's say, are going through. And so it is biologically inspired, but there's so much more that could be added, like leaves, the nutrient content. And so, yes, there is a lot that it could be very educational as well.
Yes, and I guess that's what you meant when it's a very like it's the first step towards creating this simulation modeling game, so to speak. So like you said, there's many other layers that and complexity that would have to unfold for us to have like a whole plant. And then I'm guessing there's different types of plants, right? Like there's some plants that naturally curl. Um, do you often get people asking you questions as if you were a botanist and not as an engineer? Like, how do you take care of my plant, or what's the difference between this plant? Like, do people get confused?
Yes. Yeah, I can be walking and be like, yeah, so what tree is this? And I'm like, what? um, I don't know. I mean, I'm trying to be better because I feel like I should know a little bit, but really that's it. And I'm a bioresource engineer, which used to be called agricultural engineer. I did all my degrees in it, but I'm not. Um, I do delve into plant science and my master's as well, but it really I'm an engineer at the end of the day. So it's really difficult when they're asking me also about pest questions that they have in their own house on their like succulent plants, which is something I never look at. It's funny.
Yeah, I remember when I told people I was becoming an engineer, and that they would start asking me if I could help them fix their car, and I'm like, completely different. Like, you don't want me anywhere near your car. Yeah.
I'll do you and me a service
That's
by stepping away.
I can buy you a plant though. Put it in the window. Yeah. Well, I know you have done some research, right, into plant science, because obviously you need some inspiration, but what are the one or two things that you discovered in that line of research that you felt as an engineer most fascinated by? Was it like the predator changing bitter leaf finding, or was there something else?
Yeah, so the field that I'm in, or the lab that I've been part of for my master's and my PhD, it's all about controlled environment agriculture. So it's like indoor plant production. So we're talking like vertical farms. Here in Canada, cannabis is now legal, so it's pretty big on that too. Space applications like farming. like very controlled, very quirky experiments of like, hey, let's inject a lot of CO2 in this room and see what happens. Or like, oh, let's try and like have different kind of colored lighting for X amount of time on a plant. Or, oh, let's like for my master's, we designed substrates to grow out of concrete, to grow plants in concrete. It's like kind of a fun sandbox environment to test stuff that is not necessarily in the real world or typical form of agriculture, because there's a lot of things to look at for like precise or controlled environments. And so one thing on my side for electrical signals, I think the cool finding was when we were developing the sensor, well, this was one of the big findings, is for fun, I changed the direction in which we were measuring. So like the positive, like shooting 3.3 volts here, measuring upwards. Well, we flipped the polarity. And in fact, what was really crazy was, well, it's not the same. So what's happening here in real time? And that became kind of a finding in itself, was like, oh my God, I don't think people have looked at this. Or like, do even people talk about direction of measurement? Kind of open a box of, or like a can of worms, just of like, oh, there's so much more we don't know. Also, why is it doing it like this? Why is it reacting different in this direction with respect to that one when it's under this light? And so that was fun, but then you can also just keep digging, and there'll always be questions at the end of the day.
Yeah. I could imagine. I think when you flipped it, like, okay, why should it change? I suppose you have a few reasons, like some speculations as to why it could change. I mean, there could be some sinks that you were being exposed at the root. I'm guessing maybe bringing in an electrical engineer to review it as well would also be super fascinating, because they have a different way of seeing the world.
Yeah.
Yeah. What about the lights? Because I thought that was an interesting approach. Like if you change the wave, like the light color, so you're effectively changing the wavelength that the plant is exposed to. At first, you did it for fun, just because, like, hey, it was something, probably like you had the equipment, it was there, you could do it. But when you saw that it did respond differently, did you have any ideas? And here you can speculate, and like I won't take you out of context or anything, but why do you suppose that you saw the change in responses through your measurements when you altered the wavelength?
I think there was a change in response because one, well, plants, how they capture their energy is through light. And so it makes sense if there's, when we think about light, we're outside under the sun, but there's a whole lot of different colors in the visible spectrum, but it's even beyond that. So if we're looking at one specific one, its energy charge is kind of different because the speed, let's say, of light. It sounds really specific, but yeah, the wave, the frequency isn't the same, and so it makes sense. And also, the plant is capturing energy via light through photosynthesis, and so if you're giving it only a specific color, it's not photosynthesizing probably in the same way. And then after, you could see its morphology change over time. But I think that's definitely one of them. And two is also like, why are certain colors giving different signatures too? Because you can see similarities between some of them. And you can see that also the fluctuation of the signal might be bigger due to, let's say, blue versus red. So I think that's one of them for sure.
Yeah. Would it have anything to do with why, like when in the summer, or whenever I happen to go to gardening store, I'll see different types of plants. Some are called like low light, and some are called like, this plant requires a lot of light. Is it possible that the different wavelengths, like some plants are optimized for different wavelengths, like plants that grow best in shade, for example, versus full sun? Could it be that And again, I don't know enough about the inner workings of the cells in a plant, nor do I claim to know if there's any variation in the mitochondria that sort of are involved in transforming that energy via photosynthesis. But could that potentially be a factor, like why you would see the difference in the response to the plant because of?
I'm not too sure I understood. Like, so the low light versus highlight, how is it linked to the, like, I don't understand how it's linked to the electrical signal.
So you said that the wavelengths can differ, and some plants grow best in low light, so like more shaded regions, whereas others require like full intensity, like sunlight. Full. Is it because the plant itself may be more optimized, and what you're seeing is that optimization when you shift between the wavelengths?
So I don't think it's optimized. I think it's like, where you're born on this earth. Let's say your genetic, like how you're made is different than someone who's coming from a different continent. And I think in that way, there's this pass down of low light versus highlight. But then there's two things to differentiate: is the intensity of the light. So that has to do with the strength at which it's hitting you versus the actual frequency of the light. So there's the color, and then there's the intensity. And then by the intensity, it's like how many photons are like hitting the plant. And so when you're very close to a light versus far, that will also characterize if the plant is elongating or not. And so these are two things. Do they interplay? Yes. But it still remains that, the low light versus highlight, it still means they could still like the same colors. It's more about the intensity at which the light is hitting them. And that you can also see through the electrical signal is by changing the intensity. So what that would look like in a setup in a lab, for example, is either I'm placing you can play with the intensity of the light either by how much power you're providing to it, or also because it's proportionally inverse to the distance at which you're placing the height of the light. So that's going to change the intensity at which it's hitting the plant. And so that is where like shade versus non-shade, if there's cover over it or not.
Okay, so it's not so much the wavelength, it's more about the intensity. Okay.
Yeah.
Thank you for clarifying
So
that for me.
I don't know if I explained that well.
I think you did. I would like to go back to one of the earlier comments you made. You mentioned that if we were able to equip plants with, like, I'll just call them wearables to be simplistic, that we may be able to see or sense something in the soil that would alter, for example, the growth of that plant. So it's like it could predict, right? It's like the canary in the gold mine, right? So runs out of, or there's like a toxic fume, and then the canary dies first, right? It's more sensitive. So in this case, if you were to take that line of thinking, and if you could take like one giant step with the research that you've done now and what you know, how could that potentially play out in the future? Like if you're thinking about wearables, plants, what would that look like for us if we were actually able to get it to that point where we were like, okay, I have like this massive crop field. Do we have all these wearables on the plants? Are they drone wearables? Like, do they land on the plant? Like how, like, have you had any wild dreams about where this could go one day?
Yes, I think my visions are a little bit more myopic in the sense of I haven't thought about large scale, but I've thought about, well, first let's like what is already accessible as a plant wearable. There's this really like fun thing that people have been playing more in the art world where they connect these probes onto a plant, and they're saying they're recording the signals, and it's like plant music, And so already seeing that, and that it's a device that's well packaged, is making it look more normalized to people. And so that's one point of entry. If we're thinking about deployment for agricultural purposes, I don't think every plant having one. It'd have to be really kind of like a sexy piece of hardware and very small. Like some people are working with films, and so it's like it's sticky on the leaves, and there maybe even that you can. I don't know if you can have like a Bluetooth chip on a small printed film, and it's sending. I think for my case, I think maybe if it were in a field, it would be every X amount of plants because you're trying to get a gist of what's happening. And, you can also bank on the concept of plants communicating with themselves because they do. They communicate below ground utilizing what's in the soil as well, but they're also above ground via gas. And so there's that. And then I think in terms of where I've pictured it a lot is like kind of in biohybrid systems. So integrating a plant with a robot. And so I think that is kind of it's wearing a wearable, but it's communicating with a much larger body of tech. But it's still kind of isolating one or multiple plants. It's still small. But those are like kind of the avenues I've thought about it.
Yeah, I suppose, because now we're back to the applications, like how could we take this and really use it to, for example, preserve crops or
Yeah.
predict, a drought, or, for example, if the soil has been contaminated even, how like maybe we just don't grow crops there. Um, you mentioned that plants communicate to each other. And I'm guessing you mentioned two types. You mentioned they can communicate through the soil and they can communicate through gases. Can you tell me more about what do we know about that so far?
I mean, I think maybe Susan, I'm not too sure, but there's this woman who's on the West Coast, and it's like how plants also use mycelium as their like World Wide Web. So below ground, um, they're exchanging, for example, different types of nutrients with the mycelium, giving them sugars and essential or there's exchange either of sugars, carbohydrates. The list can go on, but there's information passing below ground in that way, and then there's also um, from plant to plant, it's usually gas at the top level, and so plants have what we call volatile organic compounds, which are these like micro traces of gases and that are there. So you think about a plant when you see it, there's maybe this like thin cloud that we're not seeing. And so that is passing if there's a neighboring plant, it can sense. And so when there is a stress or there's something else, the composition of this gas is going to change and the other plant's going to sense it. And so that's typically how they would communicate above ground. In fact, there's one conference I went to was really interesting. They wanted to know how far can they communicate, and also the stress can be passed down and probably executed below. But they were. I think this was in Japan. They put some scaffolding along this huge tree, and they cut 90% of its leaves. So to stress it out, they chop, 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 and then they measured within a radius of 2 kilometers or something, and they were seeing how far is this gas going. So the other trees were protecting themselves, thinking this was coming. And so it's kind of interesting knowing how far, they can spread a message and how much time as well.
Oh, that's fascinating. I don't know. It reminds me of a movie that I watched a long time ago. I think it had Mark Wahlberg in it, and it was essentially about how humans were just so badly treating the earth that suddenly the plants just said, okay, we've had enough of you. And then they started to release this gas that would make people go crazy and And
Yeah.
I think I don't want to spoil the movie completely for someone that watched it. But I mean, this is a movie that I'm sure it's at least 15 years old. Like it's definitely dated, but it would be interesting to learn if they were actually inspired by like some of these subtle, less known facts about how that plants actually do indeed communicate, and as we mentioned already, can respond with what we would perceive as defensive behavior. So, that's super fascinating. I'm I know I have this urge now to go and water the plants in my house. So I
You
know
hearing
that's
them
the first.
scream.
Yes. That's the first thing I wanna do, when, when the podcast ends and, we say goodbye, I think that's probably, my first action will be I'll go and water my plants. So, yeah, I'm really happy actually that you shared your thesis with me because I noticed in your thesis a couple things, well, many things, but one of the things that really stuck out for me, which I wasn't expecting to see, was that you had a poem in there. And I read the poem and I really liked the poem. And I was curious to know if you'd be willing to share that poem, or if you don't want to share it out loud, maybe just tell us a little bit about why you included it and does it mean to you?
I'm happy to share it.
Please. Yeah, I'm
Like,
listening.
should I be reading it on right
Yeah,
now?
please. Yeah, go
Okay,
ahead.
wait, let me just pull this up. Okay, just for context for whoever is listening. I've been writing a haiku every day or more than one for the last probably year and a half. And so this is a chain of them. So it's multiple haikus stuck together. Yeah, it's I think for me, they are kind of condensed journal entries or good markers of time. And so what's interesting about this one is sometimes I do write multiple of them and it becomes one. But these are actually stuck together in their different moments in time. And I thought it was appropriate because this thesis has been long. And so I was trying to make sense of it. So here it goes. The title is called Pieces Mayhem or Bananas for Chaos. Lift every rock and stop looking at the clock. What happened out there? Suddenly on stage, what's happening in my dreams? They are going to know. Find the back door, opening new horizons, nervous energy. Permission to sing, yell, scream, and or self-whisper. Clear your mind's desktop. Serendipity, a science of surprises, order is mapped out.
Each of those, so each are 3 lines, and the 3 lines are together as representing or reflecting a moment in time for you. So this was, as you said, it's not all one string that you wrote in one go. Is there, so you journal this way. Is there a reason why you started journaling?
I used to think haikus were fun and I do a little bit of them. And then I also got out of a very long relationship of 8 years and a half. And so it kind of made me think, yeah, maybe I should do something for myself. And so I started journaling. But I think the haikus were, when this happened was kind of also when I was starting to think about my thesis. And I kind of wanted to get away from writer's block and do something fun. And they became way more meaningful than just trying to counter writer's block. Because it got to a point where I was kind of hooked. And sometimes if you're grabbing coffee with someone, it's like, hey, do you want to write a haiku with me? And it's just giving yourself permission to be a little bit playful. And also you reap the benefits really when you're reading after, which I didn't think I'd enjoy reading back. Because although it may sound nonsensical, you read it back and you really have a fond memory of that time you shared with someone or where you were. And it's kind of crazy how 3 lines can actually give you a flashback. It's kind of like a little, condensed
It's like a
moment
smell
of what you felt.
almost.
Yeah, it's like a smell, exactly.
Yeah.
So it's really nice. And also the conversations you have about it, you're crafting 3 lines, but really sometimes you're having a deeper conversation with someone, or I like doing them alone a lot, but it's been really nice also seeing how people are becoming more playful or willing to play, let's say.
I did my PhD many years ago, and when I was doing my PhD, I looked at my supervisors and I thought, oh, it was so much easier for them because they only had this and this, right? Whereas now I have to do this and this. And one of them for me in the position that I held is like we had to recruit a lot more patients, and we had to, like, our data analysis was far more comprehensive. And it was because the groundwork had already been laid, and so you were like building layers on top. Now, a number of years have passed, obviously, between then and now for me, but I'm quite curious to know if you see, like, how is your impression for doing a PhD now? What do you like? Do you notice a difference in time? Because I
For
did.
sure.
I noticed. And I'm wondering if that persists somehow. And if that difference is there, what does it look like to you?
I think I put myself in one really, I always pick the hard road, unfortunately. So I tried to mesh I did a collaboration with the AI Institute here in Montreal called Mila. And you're just nowadays it's almost expected that you can code in any discipline that you're in. And I mean, I'm happy enough I got this collaboration, but the expectation of like, there's this being part of this AI world and then going back to my field and collaborating with people in all of these fields. You're with computer scientists and they've never collected data themselves. And so this speed at which they want answers or moving things forward is like very intimidating. But the flip side is, okay, they don't know what it means like being a plumber for a day and setting up a hydroponic system and doing all of this, which is, still a good hard skill to have. So there's, I think, bridging sciences of disciplines is more pressure in these times because the speed at which this other science is evolving is so much faster, and you want to be part of that wave. But your edge is you're coming from a scientific direction or field that is specific to itself. So there's that. And then there's also the access of information. I'm thinking about people who used to do PhDs and they go to the library to go check on this book or even studying for their comprehensives. It's like, well, I have access to PDFs all over. And so the amount of information I need to know feels much greater. And to top it off, now it's also with all these large language models that are out and people using, large language model, we can say ChatGPT is one of them. People were going crazy. And also just like dependent on technology, or like you can Google anything, is quite interesting. And also the type of writing you're doing. Yeah, times have changed for sure.
Sounds like it. I think actually you are touching upon a really like serious point as well, where you have one area, like one field or discipline that is accelerating. But at some point, one could imagine that acceleration will be hindered. And here I'm talking about AI and the many umbrella applications that exist under that. That we get to the point where you said, like, if I have to go and set something up in the lab so that we can get just a hint of data, that's going to take a much longer period of time. And by the way, it requires other types of physical skill sets that you don't train all the time. So you have to learn them or relearn them, or you have to do all the smaller stuff first, and you have to find all the materials and the equipment, and then you have to test to see if it works. And I mean, the parallel to that is like when we see, we have the ability to process, we have insane computational power now, but we don't have the data for it. We see that in health science a lot as well.
Yeah.
Like I remember getting like if I had like 20 or 25 people in a group for one of my PhD projects, like I was really happy. Like that was a big number for me. But even through the course of my years at the university, when I saw new students come, I saw new PhD defenses, I started to see like patient sizes of 50 or 100, and I'm like, wow, that would have been an entire PhD project for me. If I had 100 patients, I would have divided them into 3 and would have done 3 separate studies. So, and then you tag on the amount of information that you have to read. And then if we throw in the fact that probably more than 1 out of 10, I would probably flip it the other way and say that 1 out of 10 is actually done correctly. So you have to filter out all the stuff that isn't quite describing the situation as they should have. So you really get misled, or you follow a dead end. We've had that with a PhD as well. So I can understand that PhD projects are taking longer to complete, especially when they have like lab if they're lab-based work.
It's a one-person show, at the end of the day. I came in with all these ideas, but I wasn't a hardware specialist. I had to build my own boards. Okay, I could grow hydroponics, but then it's like, okay, you're under-evaluating the amount of time it takes to make a full setup in the lab. And then it's like, oh, now that I have all this data, okay, I'm going to try and get collaborators, because I know I'm not the strongest one, let's say, in network analysis. So I really want to work with them. I'll go get them, but you're still steering the ship. They'll give you all the inputs and free advice they want, but it's your project. So it's like, you kind of have to be a jack of all trades, which is like, there's so much you need to be able to pull off, or it's like kind of expected in a weird way, and it's a bit daunting. Yeah,
I could imagine. I think I believe that people underestimate now what is expected of PhDs, and I also see that it's become so normalized that it's like a gaslighting problem, where the bar just keeps going up, and people are forgetting to, like, we got to pull this back. And because the point of doing a PhD, of course, is to develop skills, develop critical thinking, get some experience. But yeah, I do feel like we're running projects as if it was like a consortium effort to pull off a huge project. Looking back now from when you started, so you're in a different place, you're a different person. You're obviously very, very skilled at this point. What would be the one piece of advice that you wish you could have given yourself? If you could go back and give it, what would you?
Stop lifting rocks. No, I'm kidding. It would be probably just good enough is good enough, and that really sucks hearing it. I've struggled with this the entire time. It's like you're always striving for more. You also don't really go into academia for compliments. You always think it isn't enough. And at the end of the day, it's like someone who's citing your paper probably read like 3 paragraphs. Someone who's actually going to read your full thesis. You're trying to make your chapters are trying to be articles, so it's a currency. It's like just kind of knowing what the value is of things, depending on if you do want to stay in that field or not. And also, I don't regret going into hardware, but it was such a like that, and like trying to have my look legit in AI world too was like, maybe I tried too many things. Like,
It's possible. But it's also okay to aim high, because I suppose the alternative is if you aimed low and hit your target, as the saying goes. So it's good to aim high, and it's okay to not be like, as you said, you don't have to be great at everything. I think that the AI is a super attractive field to get more familiar with. Looking forward now, what is on the horizon for you? I know you really want to defend your PhD, so that goes without saying. You want to like get that done, of course. There's like 2 things here, right? So there's one is like the value that you created during your PhD. Where would you like to see that go? Or it could also be an and. What is the next step for you? Do you have something already mapped out, or you're just, focusing on PhD?
I'm still unsure if I want to stay in academia or not. I feel like the world is changing. They used to say like you should be changing schools and whatever. And I've done all my degrees at the same place, and I feel like it doesn't really matter anymore. It's really what you've worked on. And I also think academia feels a little bit, I don't want to say medieval, but there's things that need to change. I also feel like the world has changed a lot. Like there's more decentralized things. Like, what is democracy these days? I mean, I don't want to get political, but it's kind of a weird time to be in. And so I'm asking myself these questions like, do I sign up for a job? Do I stay in academia? And so right now, I'm very, very lucky. I kind of got roped into this AI art residency. And I think you're going to be doing a podcast with this person too.
We will
Uh,
be.
yeah,
Yes.
her name
It's
is
in
Violetta.
motion. It's in
Yeah,
motion.
cool.
Yeah.
And so we are um in this in between part of my life of master's and PhD. I worked on gender bias in AI in like natural language processing, and so this kind of really it circled back to me in a very weird way where I got to work with Violetta, and we've been working kind of on tweaking LLMs for a narrative voice, and it's more creative. But there's this whole educational component of um, can we craft feminist voices with how LLMs are these days, and kind of pushing the boundaries of like people sharing systems instructions. And even through the work I've done in my PhD, I've always advocated for open source hardware and software and stuff like that. So I think in that lens, the transparency factor. So short answer is I'll be doing that. We're going to give workshops together in the UK for creatives, and we're also exhibiting in 2 different places in Europe. So it's going to be quite interesting. In fact, I think we'll be probably maybe seeing you.
You're coming to Copenhagen, I heard.
We are,
Yeah.
yeah.
Yeah, I'm
Yeah.
gonna block my calendar. So yeah, we will definitely reconnect and hopefully meet face to face.
Yeah.
I actually, now that you mention it, I noticed that the first objective in your PhD thesis was, I actually think I wrote it out, but the key word is that you wanted XXX to be open. So it was a way, and I was thinking because you kind of blended the objective. So I just want to clarify. Yeah, here it is. So you write that the very first objective, and just for listeners, it was like around 7 objectives that you had in your thesis. And the first one was to provide open source hardware and software tools to measure plant surface extracellular electrical signals effectively. To that in that regard. So one is to measure effectively. That's an objective. And then the other one was to provide open source hardware and software tools. Now, is that objective weighted in a way that it was really about providing the open source access to your research?
I think it was more in there are tools that exist that are doing this right now, and what I'm seeing is that it feels proprietary and it's very weird. And I'm someone who's really in the camp of like, well, if we're trying to advance something, why are we making it secret here? Because they're not really even products. It's just like labs. Sometimes you do have companies too, and I learned too talking to companies measuring the same type of data as me. After a few questions, it's like, if you're doing that beautiful packaging, I'm not that far off of what you're doing. And so why are we making it inaccessible? Because this is like kind of important information and we don't know where it's going to go. So I think it was in that lens, and also lowering the barrier of entry. I'm thinking of my peers who are in plant science. Like I think I'm an engineer, but at the end of the day, I'm working a lot in the field of plant science, and plant scientists aren't going to be building hardware. They're dependent on buying or finding stuff like that. So you want that field to be also part of this golden era of massive data going in the future, being able to do all these things and not limit themselves. And I think for me, that was really important.
Yeah, I think also what I'm getting a hint of is the idea that that's not like, obviously what you're doing is innovation. When you build something, a new product, a device, tool, software, algorithm, for sure that is considered innovation per se, but maybe it's not the one that you monetize. Like maybe it's not that's not the big step that we need. We don't, like, if people keep closing and, as you say, packaging things and selling it, every little step of innovation, we're never going to get anywhere. So it's like, what are we like? We need the big steps now. We're actually in a position right now, all of us together, literally on the same boat or ship, and we need bigger steps. And here we have people hiding them behind, as you say, pretty packages.
Yeah, I think we'll also, like, similarly, just going back to working with Violetta, where we have our different strengths, but there's like this energy of collective thinking. I think it's in that way too. Collective thinking towards, like, well, we can all, if we really did want to monetize, it's like we're all working towards it. But at the end, it's like, if there's traceability of what you've worked on, that everyone can reap the benefits and maybe we can all monetize on it. But
Yeah.
at this point, it's just like blocking and slowing down things.
Yeah, and I do believe that that's part of, like, the decentralized science initiative. It's also about keeping things open. It's about, as you said, having some provenance attached to your contributions and making that available. Um, that's also that brings in the blockchain and some of the benefits of integrating blockchain technology, into science as a tool for that. I know that's not what our podcast is about today, but I was really, it really stood out for me to see that as your first objective, is to make sure that it was open and that other people had access to that. And to be honest, I don't think I've seen that as a first objective in any thesis that I've read. So I just wanted to highlight that I was surprised in a very positive way. So
Thank you.
yeah. So I guess the last step now is, your PhD defense, and what do you have left to do? So you shared a thesis with me. It looked pretty close to being completed. What is the missing puzzle? What is the missing piece to the puzzle? Yeah.
I have a few, like, I think what I shared with you was like maybe the link that wasn't fully up to, I have to integrate some comments, and then it goes to all of my committee, and then I will have a defense date. And then on the side is I have papers I need to go send out to journals. It's just kind of a pain in the ass because, yeah, like, preparing for it, getting under review, waiting months. There's one of them I need to resend because it didn't get accepted somewhere. So it's like, it's just so slow.
It can be
Yeah.
very, very slow, and it doesn't need to be. It is, but I have mixed feelings about how fast a peer review should be. I have, in one case, I think it should be as fast as possible, for sure. But the other part is, if you want the right experts to review your work, they're probably also a little bit busy, right? So it's about it's about finding that time. And I know, like, Noble Blogs, I think what we are. So we're launching a publication platform. So we're hoping to very much address the speed and also the expertise challenges, amongst many other things. So I do wish you, like, all the speed that you need
Thank you.
to get through the publication process, because I know how difficult it can be. You're in the last stretch, and
Yeah.
I look forward to meeting you in Copenhagen when you come. Yeah,
I'm excited
absolutely.
too.
It was so nice to have this conversation with you, and I am gonna go get ready so I can water my plants.
Nice.
Yeah, I'll never look at them the same again. So
Nice.
yeah. All right. Have a fantastic day, and I'll talk to you soon.
Thank you.
Thank you.